Hi folks, we're going to take a look at Unit 6, Lesson 4, Number 2. And here we're again sketching the graph of a combination function. Here we're adding two functions together, except we're not given the graphs of the individual functions, so we have to figure out what this is going to look like. All right. So here I've got an exponential and a sinusoidal. So I should think, first of all, what these functions look like individually. So if I take 2 to the x, I know 2 to the x is always positive. Okay, and it crosses at 1. Okay, and let's see what I'm doing is I'm adding to that sine of pi x. So here, this is where I think, well, I know sine of pi x only produces numbers that are between 1 and negative 1. Okay, and then of course in a cyclical sort of way. So whatever my value of 2 to the x is, I'm only ever adding at most 1 or subtracting at the very most 1. So it looks like what I'm going to have is something that is going to kind of be cyclical around 2 to the x. All right? Constantly adding or subtracting something no greater or smaller than 1 and negative 1. Now take a look at what's going to happen as x approaches negative infinity. As x approaches negative infinity, this thing approaches 0. So I'm essentially adding something almost equal to 0 to sine pi x. So it looks that as x goes to negative infinity, this is eventually just going to look a lot like sine of pi x, because I'm just adding something barely greater than 0. Okay? So I kind of have an idea of what this is going to look like. All right? So let's get some details here, because this is not sine x, but it's sine of pi x. All right, and so the period here is going to be equal to 2 pi over pi, which is equal to 2. And the numbers that I think I'm going to be interested in are where sine of pi x is equal to 0, because then that means it's just going to be the same value as 2 to the x is. And the other things I might want to look at is where sine of pi x is equal to 1 or negative 1, because that's when I'm adding the most or the least to my function 2 to the x. Okay? But instead of, figuring out what these points are, I'm just going to draw myself a graph, because if sine pi x has a period of 2, okay, we know what sine looks like. So if a full period is 2, means half a period is 1, and a quarter of a period is 0.5. Okay, so we know exactly where, this is 1.5. Okay, 1.5 there, and this is going to be, 2.5, 3, negative 0.5. Okay, so this is where our sort of special points are going to be located. So let's start by drawing 2 to the x, because then what we're going to be doing is adding, these, cyclical points between 1 and minus 1 to our function. Okay, so I'm going to keep this maybe a little lower than usual. Okay, maybe even here, because 2 to the x is going to start growing real quick. Okay, and I do want to show this idea that as I go to negative infinity, eventually this is going to just start looking like sine of pi x. Okay, so I'm actually going to put this right down the middle. Okay, so let's go up here, 1, 2, 3, 4, so negative 1, negative 2, negative 3, negative 4. And here, I guess I can go up by maybe go up by 4, although this is going to get really big really fast. I might actually go up by 2 here. 2, 4, 6, 8, 10, 12. Okay, and let's draw 2 to the x here. I'm going to draw it as a dotted line. I'll draw it in blue. So I know at 0, it's going to be equal to 1. At negative 1, it's going to be equal to a half. And then at 1, it's going to be equal to 2. At 2, 4. At 3, 9. And at 4, there you go, 16. Okay, so I know my function is going to look something like this. Okay, and this is going to be my guide for drawing this function here. And then it's just approaching 0. Okay, And so now what I'm going to start off with is those places where sine of pi x is equal to 0, because then I'm just going to have the value of 2 to the x. So where's sine pi x equal to 0? Well, that's 0. So there's going to be 1 point on my graph. Okay, and then where else? At 1, at 2, at 3, at 4. So we know that 0 plus 2 to the x, it's going to be whatever 2 to the x is equal to. Here, whatever 2 to the x is equal to. Okay, and now minus 1, and minus 2, and minus 3. And we see here it's essentially almost at the y-axis. Okay, so this is where I'm not going to go crazy trying to figure out exactly what these values are going to be, but we have to figure that as I get closer and closer to, negative infinity, it's going to look more like 2 to the x. So let's take a look at what sine x looks like here. Well, sine x first is positive, so I'm going to be adding. So in this area here, I'm going to be adding to the function. And then in this area here, sine x is negative, so I'm going to be subtracting from 2 to the x. Here I'm going to be adding. And then here I'm going to be subtracting. So my function looks something like this. Okay, then I go to the left-hand side. First I'm going to be subtracting, then adding. Okay, and you see here is I'm pretty much going to be going much more regularly here between 1 and negative 1, because 2 to the x is so close to 0 it barely has an effect on the 2 to the x. So my function is going to look something like this. Okay, more or less between 1 and negative 1, and then as 2 to the x starts to get bigger and bigger and bigger, and I'll have something that looks like this. All right, so let's go back and recap what we did. So number one, we realized that we had 2 to the x, and we were adding a function that only goes between 1 and negative 1. Okay, so we know that sometimes we'll be a little above the function, sometimes a little below the function. Okay, nice points to look for were where sine of pi x was going to be equal to 0, so that we know when this whole thing would just be equal to 2 to the x. So that was very useful for finding nice points to use. Okay, and then from there we just had to work where sine pi x was going to be positive, so we were going to be above 2 to the x, and where it was negative, we were going to be below 2 to the x. And the other thing to draw a nice graph was to realize that as 2 to the x was approaching 0, the total function was just going to start looking more and more like sine pi x. Okay, that's it for this one.